Hi students, today we will discuss one important topic now, that is rotational motion. In that we will discuss moment of inertia. Most important for JEE mains, NEET, IIT Advance, no, every time compulsory question will be there. Without question from this one, no, there is no paper at all, right? So concentrate on to this thoroughly. Thoroughly we will discuss about the moment of inertia in one or two parts, no. So we will get clear information, complete information related to the moment of inertia now. First of all, let us go for rotational motion now. Rotational motion means what? An object is rotating about its axis. Like one fan is rotating, our earth is rotating now. Therefore, a spinning top, a wheel, a fixed wheel, no. Therefore, it is rotating now, right? So, like that. So, if an object is there, it is rotating now. So, now rotational now. Suppose there is one object is there, no. One object, you are going to take it, no. This is one object is there, one general, one object is there. This is one object. Now this object is rotating like this. So this we'll call it as like your axis of rotation now. So this is having large number of particles onto this one. No? So let us see one some particles we will take it. No, this is the axis of rotation. So this is one particle is having mass m. It is a distance is r1. So this is also particle m2 having a distance is r2. Another one more particle is there. Suppose m3. So distance is r3. Now like that so many particles will be there. These are the distances, perpendicular distance from the axis of rotation, right? So if whole body is rotating, therefore whole body is rotating, no, therefore it is rotating with an angular velocity is omega. Can you tell me what it will be the same for all these particles? No. So for all these particles, so angular velocity will be same, that is time period will be same now. That means this particle will be undergoing the form of like a circular path, but it will complete in the same time as whole body is rotating now. That means angular velocity of this particle, angular velocity of this whole body, it will be the same only. This particle also revolving in the circular path, but angular velocity will be the same. Also it is revolving in the circular path, no, angular velocity will be the same, right? But what about the linear velocity? This is very important, no. Linear velocity of the each particle is different, right? So that means this particle is having linear velocity, so therefore it is having v1. So what is, we know the formula from the circular motion, v1 is equals to r1 into omega, angular velocity same. So what will be the linear velocity of this particle, no? So v2 is equals to r2 into omega. So what is the linear velocity of this particle, no? That is nothing but a r3 into omega. Clear? So linear velocities are different, angular velocities are same. The axis, because the masses are same and distance is also different from this one now, right? Masses will be the different onto this, right? Now we want to calculate the total energy associated with this rotation now. Total energy. What is the total energy now? So that is nothing but a total energy. So what is the total energy here now? So total energy will be equal to kinetic energy. So that is nothing but a, so kinetic energy of this whole body is nothing but a kinetic energy of this total particles onto this. What is the kinetic energy of the particle now? Half m1 v1 square plus half m2 v2 square plus half m3 v3 square. Like that so many particles are there. The total energy of all the particles, no, will be equal to total energy associated with that rotating body now, right? So here, so we can write down v1 we can write it as half m1, v1 value is nothing but how much now? So v1 so is equals to r1 into omega whole square, so plus 1 by 2 m2 into r2 into omega whole square plus 1 by 2 m3 into r3 into omega whole square, so on. Clear? So if you simplify onto this one, no, what you will get it now? Half, therefore m1 r1 square plus m2 r2 square plus m3 r3 square, so on, of all the particles into omega square. Clear? So now we know that kinetic energy of the particle, what is the formula? Kinetic energy, it will be equal to translational kinetic energy half mv square. This is translational kinetic energy. This is half is there, here also half. Here translate, that is velocity, translational velocity, here angular velocity. Here mass, here that is mass is nothing but inertia. Here this is nothing but a moment of inertia. That means this is nothing but a moment of inertia. Moment of inertia, right? That means how that mass is showing the same property in the translational motion. What is that inertia? Inertia is nothing but a resistive to change. That means if an object is at rest, to convert into motion, no, therefore it will show some opposition. That opposition we can call it as like a inertia. Similarly, every object if it is want to rotate, no, to rotate that there is a certain amount of opposition, it should show that opposition only we will call it as like a moment of inertia. So we can write down kinetic energy due to rotational. So we can write it as half I omega square. This is your kinetic energy due to rotational. So this is I is nothing but a moment of inertia. How the mass is playing the role in translational motion. So moment of inertia will play the same role in the rotational motion. So this one only will calculate fully on these topics, no, part 1 and part 2, how to calculate the moment of inertia of the different things now, right? So we'll see. And here also one more important point, no, that is the particles which are lying on the axis of rotation. The particles which are lying on the axis of rotation, no, so they are not moving at all. So therefore the particles or the masses which are lying on the axis of rotation, they are treated to be at rest. So they are not rotating onto this one. What are the particles which are there, no, which are lying on the axis of rotation, they are treated to be at rest. Now we'll go for moment of inertia. Most important, moment of inertia. Therefore this moment of inertia is nothing but a resist to change, right, in rotational motion. Now what is this formula? That is nothing but a m1 r1 square plus m2 r2 square plus m3 r3 square. These are the three particles we studied, like that so many particles now. We can write down I is equals to summation of I is equals to 1 to n. So mi therefore ri square. This is your moment of inertia if you know the particles now. Therefore what is this unit onto this now? What is the unit now? What is the SI unit now? SI unit of the moment of inertia is nothing but a mass into distance. Therefore kg into meter square. So therefore dimensional formula. So dimensional formula is nothing but a m1 L square. Therefore is a vector or scalar. So therefore it is a tensor now. Therefore the tensor is nothing but a, so different axes. Therefore it will be having different possible values now. So in different directions. So moment of inertia will be having so many other values now. So it's not a vector, it is a tensor now. But how to solve it now? We can treat it like a scalar quantities only, not like a vectors. Clear? So this is a moment of inertia. It depends on what factors now. So moment of inertia depends on mass and mass distribution. Therefore it depends on what? Mass distribution, mass and mass distribution, and chosen our axis of rotation. How we are choosing? Therefore based on the axis of rotation the distances are also changing now. So therefore here moment of inertia also will be changes onto this. Here we can define one more moment of inertia. So formula, no, therefore here we can take it as, right, I is equals to therefore total mass into k square. What is k now? K we can call it as like a radius of gyration. Radius of gyration. What is this radius of gyration now? We can rewrite it as I by therefore m. So what is this radius of gyration now? This is nothing but the effective distance. So instead of taking each and every mass, no, the total body, for total body there is some effective distance we have to take from the axis of rotation. So that whole total mass it will be concentrated at that point. It is taken as like a effective distance from the axis of rotation now. So what is the unit for this one now? So radius of gyration I is equal to mk square, moment of inertia kg meter square, therefore kg cancel, meter square. No? So therefore it is nothing but a meter is a SI unit is what? SI unit is nothing but a meter. Dimensional formula, it is nothing but a L only. Clear? So what is the radius of gyration? No, it is nothing but a effective distance from the axis of rotation. No, clear? Now, so in mass distribution also we can write down different formula. At that time, continuous mass distribution, no, we'll do that concepts, no, at that point. Right now, we'll do the questions based on this concept now, right? I is equals to m r square, right? So now let us see one question now. So we'll do this question only fully onto this. Suppose let us take this masses, no, it is m, right? And another one more mass is m. Here also it is m. Here also it is m now, right? So can you tell me how many axis of rotation can be taken onto this one, right? For a one body, how many axis of rotation can be possible, right? If possible, you can please comment it, no? So how many axis of rotation? Therefore, how many ways you can rotate this book, no? If you know, please comment it, no? We know that some rotations, no, so many students, what they will do, they will rotate like this. Therefore, they will rotate like this now. Clear? So therefore, not only this axis of rotation, no. So if you know, please comment it, no. If not, just see, no. See here. Therefore, here I can rotate like this, no. This is one rotation, right? One more rotation, no. Along the diagonal, one more rotation, no. Like that, so many people will take 5 or 10. But there are infinite number of axis of rotations are possible onto this. That means you can rotate it here from here, no. You can rotate it from here, no. You can rotate it from here. So from here, each and every point along this one, no, right? So we can rotate it. So like that, we can rotate it like this, no. So we can rotate it like this. Therefore, infinite number of ways we can able to rotate this book onto this, right? So that means how many axis of rotations are possible, no? Infinite number. So in these questions, no, defining the axis of rotation is very, very important. In the question, also understanding the axis of rotation is very, very important, right? So here there are the 4 particles are there. So 4 particles of mass m and therefore separated by some distances L. Now we want to calculate the moment of inertia of different combinations now, right? First of all, let us go for first one now. What is the moment of inertia of an axis passing through? Very, very important. Listen carefully. Axis of rotation, no? Axis passing through the center of this. Center and perpendicular to this one. Therefore, this when we want to calculate. So that is nothing but a here. So it is at the center here now, right? Axis of rotation passing through the center now. We want to rotate like this. Clear? How the particles will move? These particles will move like this. This particle will move like this. This particle will move. So like this. All these particles, right? So therefore, axis of rotation. So passing through center and perpendicular to the plane, or it is passing through the geometrical center onto this. Clear? So how you can write it now? Moment of inertia. So I1 we can write down. So this mass and distance. Distance is how much now? This is total distance is root 2 into L. So this distance is L by root 2. Like that, mass is same, distance is same. 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 So therefore here 4 into m into distance square. Distance is nothing but L by root 2 whole square. How much it will be? 4m L square by 2. So therefore it is 2. Therefore 2m L square. Clear? Most of the students, most of the examinations, no, they will ask you what will be the radius of gyration onto this. So radius of gyration, no. So radius of gyration you can write it as k is equals to I1 by total mass of this one, total mass of the system. What is the total mass of the system? 4m. Clear? So therefore here it will be 2m L square by 4m, no. So it will be by 2. Therefore L by root 2 will be your so radius of gyration onto this. Clear? So now we'll do one more question, no. So we can have a lot of questions on this, right? So we'll find the moment of inertia of this one now. So if an axis passing through any one of the vertex like this, therefore suppose it is I2. So what is the moment of inertia now? So if an axis passing through, axis of rotation, so passing through vertex and perpendicular to the plane. like this. They will give so many, right, acts of rotation like this, no? You need to understand it, right? So here we are rotating onto this. That means if I am rotating, no, this mass is at rest, no, this mass it will be rotating, no, this mass is rotating like this mass is rotating like this. So therefore only three masses are there. This fourth mass is at, therefore it is at rest now. I2, therefore this distance is same mass, therefore it is 2 into ml square plus this distance is how much now? Root 2 into L. Therefore, here m into root 2 into L whole square. So, this you can write it now. Totally it will be equal to 4m L square. This is your moment of inertia of an axis passing through the any one of the vertex. What is the radius of gyration here now? So, radius of gyration means nothing but again I2 by 4m. So, you can write down. So, here 4m L square by 4m, therefore it will be L will be your radius of gyration onto this. Clear? Now, now we'll see one more question onto this one. It is m, again it is m. Therefore again it will be L, right? Now an axis of rotation passing through, right, of an axis of rotation passing through, so axis of rotation passing through any one of the diagonal. So passing through the diagonal onto this. Clear? How to write it now? So this it will be your I3. So I3, what you can write it now? This it will be your perpendicular distance. See, if you are rotating like this particle is revolving like this particle is also revolving like this. So therefore it is L by root 2. Therefore it is 2 into m L by root 2 whole square. Therefore ml square will be your moment of inertia of an axis passing through the diagonal onto this. What will be the radius of gyration here now? That is I3 by 4m. So therefore here ml square by 4m, therefore L by 2 will be your radius of gyration onto this. Clear? So we'll do here one more moment of inertia. So of this one, no. So if an axis passing through any one of the side, right? So here I am rotating, no. Therefore this is your I4. What is axis of rotation, no? Axis of rotation passing through any one of the along the side. So what will be the moment of inertia here now? Therefore it will be ml square plus ml square. So 2ml square. It will be your moment of inertia if an axis passing through any one of your side of this one. Clear? So, right, what will be the radius of gyration here now? Radius of gyration is nothing but 2ml square. So by therefore 4m get cancelled out. So therefore L by root 2 will be your moment of inertia onto this. Clear? We will calculate the moment of inertia. So now we'll see here an axis of rotation passing through at midpoint of this along the side, along the midpoint and perpendicular to the plane now. Therefore this is your I5. What is the moment of inertia? Is passing through one of the side perpendicular to the plane, passing through the midpoint onto this. Clear? So this one, what you can write it now? This midpoint means this is L by 2. This distance is also L by 2. These two. So what is this distance now? This distance is nothing but so like Pythagoras theorem, you can write down. Therefore root of L square plus L by 2 whole square. So what you will get it now? L square plus 4 this 5 L square by 4. That means 5 root 5 into L by 2. So this is nothing but root 5 into by 2 into L. This also it will be the same. So therefore this I5 you can write down. Therefore here these masses are same, distance is same, mass same, distance is same. So therefore 2m into L by 2 whole square plus. So this distance and masses are still same. Therefore 2m into root 5 into L by 2 whole square. Clear? So simplify this one. Therefore 2m L square. Therefore 2m into L square by 4. Therefore it is 2. So therefore 2m into 5L square by 4. Therefore by 2. No. Therefore what you can write it now? Here ml square by 2 plus 5ml square by 2. Clear? So 5 plus 1 6ml square by 2, that is nothing but 3ml square. In this way you can calculate moment of inertia So if an axis passing through any one of the side, perpendicular to the side, no, and perpendicular to the plane passing through the center of this one. Clear? So we'll do one more question, no, one more final question on this one, no. Let us see. So here there is a mass is there. Okay, we'll see here, no. So here there is a mass, therefore here the mass. Here there is a one more mass is there. Here mass, no. Here it is M. So side it is L. Now here this question, no, it is asked in the examination, no. So we'll take one axis, no, so which is passing through the vertex and parallel to the diagonal of this one, no. Therefore we want to write it, no, this is I6, axis passing through the any one of the vertex which is parallel to the diagonal of this one, right? So we want to rotate it now. That means if we are rotating like this, that means this particle is rotating like this particle is rotating like this particle is rotating like this now. Clear? So now we want to calculate the moment of inertia. This is asked in the recent JEE main examination, no, JEE main question, no. This is your JEE main question, right? So now we'll see what is this distance now. This distance, right? What is this distance now? This distance is nothing but L by root 2. This perpendicular distance you can write down L by root 2. This distance is nothing but root 2 into L. Clear? So what is the moment of inertia? I6. So both masses are same. This is at rest, no? These two are same. Therefore 2 into M into L by root 2 whole square plus, so this mass is M into, therefore root 2 into L whole square. Clear? So what you will get it now? 2M into L square by 2 plus M into 2L square. So this will get cancelled, ML square plus 2ML square, totally 3ML square. So will be your moment of inertia of an axis, this one now. Clear? So like this you need to calculate so many other combinations, no. We'll see one more concept here, no. One more question now. One more question, very important now. Let us see. Similar type, therefore if mass is there, so these are the masses which are kept at the vertices of an equilateral triangle now, right? Now if you want to calculate moment of inertia of an axis passing through the any one of the vertex perpendicular to the plane, this is I1. So I1 can be written as this distance is same, therefore 2ml square will be your moment of inertia. What will be the radius of variation for this one now? So it will be nothing but I1 by 3m by m 3m, therefore root 2ml square by 3m get cancelled out, no. So therefore here it will be, so 2 by 3 into L, so therefore this it will be your K. Clear? Now we'll see one more. So moment of inertia of an axis passing through any one of the side here now, therefore this is your I2. Clear? So you should know these two masses are at rest now, but this distance you should know it now. This is your height of the equilateral triangle. What is the height of the equilateral triangle now? So what will be the value? This, you know, this angle is 60 degree. So this is your L, this is your opposite side. So sin 60, it will be equal to, this is your H. So H by L. Therefore H is equals to, this is root 3 by 2. So root 3 by 2 into L. So height is equals to root 3 by 2 into L, right? So only one particle is there here rotating now. This particle will be rotating like this. I2, therefore it is nothing but so M into, so root 3 by 2 L whole square. Therefore 3 by 4 ML square will be your moment of inertia. Clear? One more important question, no? One more most important one now. Let us see. Here mass is M and here also mass is M. Here is also mass is M. Therefore, of an axis passing through the center of this one. Clear? This is a centroid. Centroid means what you should know now? You should know this distance. Clear? So what is this distance now? This is your height of the centroid now. How to calculate it now? This also same. So this is also same. This one, right? This distance is same. Or you can write down this is L by 2. This is your 30 degree. So this distance we want to calculate. This is your adjacent side. You know that cos 30 adjacent side by hypotenuse. So adjacent side is nothing but L by 2 into this is your x, no, x. Cos 30 is nothing but it is root 3 by 2. Therefore, this 2 to cancel, no, x is equals to L by root 3. L by root 3. This distance is how much, no? It is L by root 3. L by root 3. L by root 3. Right. So here we want to calculate the moment of inertia. Suppose this is your I2, I3. So therefore I3. So same distance, therefore same masses, no? 3 into m into L by root 3 whole square. So therefore 3 ml square by 3. So therefore ml square will be your moment of inertia of an axis passing through the center of this one. Clear? So in this way, different combinations, no, you need to solve the problems onto this. Clear? One more question, no, here. So suppose these all are the masses, no, so which are kept at the corners of a regular hexagon, no, regular hexagon, right? This is L, L and L, right? So we want to calculate moment of inertia of an axis passing through the center of this one, no, where the diagonals are intersect, no, right? So which is passing through the center perpendicular to the plane. So you know that hexagon means you should get into your mind. So if you draw like this, no, all these diagonals. So this hexagon, no, it is nothing but it divides into 6 equilateral triangles. 1, 1, 1, 1, 1. Totally 6 equilateral triangles. Equilateral triangles means all sides are same. So this is L. So same distance, no. So therefore here I1, what you can write it now? The total distance is the same, masses are same, 6 into m into, so L square, therefore 6 ml square will be your moment of inertia of an axis passing through the center of this one. Clear? So now we'll see one more question here, no? So one more question. This is your frequently asked in the NEET and JEE mains, no? Let us see. So we'll take therefore here, suppose 3 kg object is there, no, which is kept at 2, 3 distance, no. So therefore here 4 kg object is there, no, which is kept at 1, 2, right? So we want to calculate the moment of inertia along the x-axis, and moment of inertia along the y-axis. Very important, no? So be clear, no? So on this concept, so many students, no, will get confused. First of all, let us plot this one, no? Therefore this is your x-axis and this is your y-axis. So where it is there, no? Okay, we'll see here. We'll take another point, no, so that's slightly difficult onto this. -1, 2. Okay. So therefore here where is the points are there, no? So here 2, 3. That means 2 means along the x-axis is 2. So along the y-axis is 3. That means here, no? So where it is there, no? This is 3. Okay. So here 3 kg is there now. 3 kg. Keep in mind. Okay. So 4 kg. Where the 4 kg is there now? 4 kg. So -1 means along the x-axis. So therefore here -1 is there. So along the y-axis 2 is there. Therefore here it is 2. So here it is 2. Therefore here it will be your 4 kg is there now. Clear? Now we will see right how we are going to calculate it now. Like that, so many particles they will give you, know, you need to calculate. What will be the moment of inertia along the x-axis now? Therefore I want to rotate. Therefore along this x-axis, no, I want to rotate like this. That means how the particles will move? This particle will move like this. Yes or no? So this particle will move like this. Why I am not taking maximum, no, so that you will understand very clarity here now. If I am rotating along the x-axis, what should be the radius should take now? You should take the radius as nothing but a y-axis distance. So most of the students, what they will do now, x-axis means x distance only they will take. No, wrong answer. If you take it along the x-axis means, so it is, what is the radius now? What is the distance here now? Distance is nothing but how much distance along the y-axis. Clear? So that simple thing, if you remember that now, you can able to calculate very easily. So moment of inertia along the x-axis means y distances. Y distances is what? Here 3 and 2. So therefore what you can write it now? 3 into, therefore 3 square plus 4 into 2 square. So what you will get it now? Here moment of inertia. So therefore 3 into 9 plus 4 into 4. 9 3s are 27 plus 16. So 7, therefore 13. So 13 1 4 3 4 43 kg meter square. Clear? So in this way you need to calculate moment of inertia along the x-axis. So suppose along the y-axis, how it will be there? So be careful. Again, you already understood the logic, no? If you are rotating along the y-axis, means how the particles will move? These particles will move like this. Clear? This particle will move like this. That means this distance is what? X-axis distance. So y-axis means x distance, x-axis means y distance. That's all. If you remember these points, no, you can calculate very easily. Iy, that is nothing but a 3 2 square plus 4 into minus 1 whole square. What do you get it now? 3 into 4 plus 4 into 1. So 12 plus 4. Therefore, it is 16 kg meter square. This is your answer. Clear? In this way, you can solve the problems very, very easily. So, if they are allotted onto this. Right? Right, students? Like this, basically, you can calculate the moment of inertia. So, in the next part, no, we'll do parallel axis theorem and perpendicular axis theorem and applications, and continuous mass distribution also we will do it, no. So thank you for watching. So please subscribe to my channel now.